Hey, good morning, everyone. Another beautiful day in New York City. And, well, let's go. We have a long program today, and we're starting with Denny Vrandečić for a keynote. And Denny is at the Wikimedia Foundation. Denny is also the founder of Wikidata, you might have heard about or used. If you haven't, you should take a look. And Denny, the stage is yours.
Thank you, Francois. Thank you, Francois, for inviting me. Francois asked me to come here and present, and he asked me, what topic do you want to talk about? And I was like, oh, Wikidata and Wikifunctions. And, you talked about this last time you were here. Give me something new. And I was like, oh, okay, well, every day someone's talking to me about large language models and how it does this do with knowledge graphs, basically every day for the last year and longer. Maybe I can talk about that. And he's like, oh yeah, that's perfect. Let's have him talk about this. And like, okay, cool. Until May, I'll have something to talk about. Now it's May. And I had a really hard time to come up with what exactly I want to say. These things are changing so quickly. It's so difficult to keep up, and everything seems to be new. So I recently stumbled upon this quote here in a book that I was looking for for something for my daughter to read. When in doubt, you can't be wrong. And the big advantage is I'm a lot in doubt right now about the whole thing. I don't know what the future of knowledge graphs will be, obviously. And LLMs are changing very, very quickly in these things. But as I said, for a decade or so, I've been talking with a lot of people in this area, and maybe I have something worthwhile to say that's worth your time right now. So, but there's one thing I have no doubts about. Something big is happening. So this is from Diffusion of Innovation, the book, this early adopters. Oh, sure. I forgot to take this off. Sorry. Okay. Better? Perfect. So this is from Diffusion of Innovation. You see the early adopters and everything. My brother, he lives in a Croatian town on a small island, 180 people. He's approximately here on this thing. So, and last fall, he called me to talk about stable diffusion and image generation. So yeah, it's obviously a big thing. Within 2 months, in record time, ChatGPT managed to get more than 100 million users. This is an adoption we haven't seen ever in any technology. There's going to be a lot of impact on the world. Last year in September, that's 2 months before ChatGPT was released, we had a meeting of researchers and practitioners in Dachstuhl in Germany to talk about knowledge graphs in the 21st century. Some of them are here. Hey, Deborah. Anyone else from this group? There, Juan, sure. And the report is out now, you can read it. So I'm trying to distill things from the report. I'm trying to distill things from other talks that I had and to bring up together what we were talking about. But one feeling that I had from that conference and also from others actually is that we are in a kind of shock about what these LLMs are doing, can be doing. They were kind of processing through it. And we're trying to figure it out and to realign our worldview around it and how this works together with the stuff that we are working. Second disclaimer. Nothing in this talk is generated by an AI. This is not one of those talks where at the end I say, and this was generated by an AI. So no, it's not one of these strict things. If something is generated, it is explicitly marked, and you will know it. It's not that I'm going to lead you on and haha, and I did that. Finally, last disclaimer. It is very narrowly focused. It is about knowledge graphs and LLMs and how to react with each other. I'm not talking about the ethical stuff about LLMs, or the copyright things that they have to do, or what the implications are of training it, what the implications are for small languages and so on, whether it will destroy the human race or not. Some of these topics are very interesting. I'm not going to talk about them today because I only have 25 minutes. So What makes me believe that there is a future for knowledge graphs in a world of large language models? Well, about 6 or 7 years ago, I was working at Google and the Google Knowledge Graph. And back then, it was already visible that this is going to happen. So we were asking the question, we are putting a lot of resources into the Google Knowledge Graph. Is this a good investment of our resources? There are a lot of people working on it. There are still a lot of people working on it. So Google hasn't changed its opinion too much on that, it seems. Should we stop investing in knowledge graph or not? So I'm going to give you the same answer that I came back then. Let's look at first principles. It's always a good way when you're at Google. So what is a knowledge graph actually? A knowledge graph represents things and their relation, usually stored in a graph database. You know, they don't have to talk to you about what knowledge graph is. Wikidata is a good example of that. It's the largest publicly editable and you can just access it. What's a large language model? Well, it's a model. It's a neural network with weights that is trained on inputs to make a certain output come out. And when you get a novel input, you want to make a reasonable novel output for that. It's a language model because it's trained on a lot of language text, of natural language, and it's large because it's trained on a lot of those texts. And it has a lot of weights. GPT, that's the currently popular ones. GPT is a family of large language models created by OpenAI. We don't know any data about GPT-4 because even though it's called OpenAI, they're not particularly open anymore. GPT-3 had 96 layers with 175 billion weights or parameters on it. So it's large. As a large language model, GPT has been trained to provide appropriate answers to a given prompt. And then there's ChatGPT, for example, where you can ask questions. So for example, for the following input, who created the School of Athens? It answers me that Raphael created the School of Athens. The answer is really good. It gives him nice context. The answer makes a lot of sense. It's correct and everything. It's really beautiful. Not much to complain. If I ask the same thing to Google, I even get an even more amazing answer. You know, I get context, I get information about Raphael, I get other people that are being searched for. It's beautiful. I can also ask the same thing to Wikidata in a Sparkle query, so it's not that pretty, and the result is also not that it may, but it gives me the right answer in all of these cases. But here's one thing. So ChatGPT took about 5 seconds to generate that answer. And Google took about half a second to generate the answer. And both of them give me a lot of context, but still, it takes quite time. Wikidata took about a quarter of a second to give me the answer. And that's not all. ChatGPT is running on the fastest and most expensive hardware you can get. Google is running on the fastest and most expensive hardware you cannot get. We are running on years-old abandonware on a single server. And nevertheless, we are so much faster. And if you think about it, it's not surprising. The query I asked had 6 tokens, actually similar to words, and the answer had about 60 or 70 tokens. I could train it to give me just a 2 or 3 token answer. Raphael is much shorter than the whole sentence it gave. But still, just a parsing took about a second. And it has to run every single of those tokens for 96 layers and multiply 175 billion weights of each other. It's a lot of multiplication going on there in a lot of CPU. In Wikidata, I look up something out of 100 million items. I look up something out of 10,000 properties. Both of those are logarithmic operations. They are so much cheaper by necessity. Given this paper here, 1,000 Wikidata queries, like the one I asked in the cloud, would cost about 14 cents. The author thought it's too expensive, so they bought their own hardware, which made it even cheaper. But this is in the cloud now. And we're going to compare with the cloud again, because you can't run GPT-4 on your own hardware, because GPT-4 is not available, not to mention that you couldn't buy the hardware for it anyway. So GPT-4, having this 1,000 query run, costs about $7.56. That's a factor of 50x. So you can use LLMs for this kind of thing, or you can use the knowledge graph. If you have that money, it's fine. But there are other problems with it as well. But I don't know how robust these numbers are. I can give you all the references and so on. And I do expect that the numbers will go down in the future, but still, there will necessarily be a very big difference because of the first principles of how a knowledge graph works and how an LLM works. You won't get around multiplying billions of matrices in one case, whereas it's just a lookup in the other. Even Sam Altman, the CEO of OpenAI, described the compute costs of ChatGPT as eye-watering, and he got a really sweet deal with Microsoft to run it all on Azure. John Hennessy, chairman of Google and former computer science at Stanford, so he really knows what he's talking about, said that running a GPT like Google would cost about 10x on every single query. So even Google can't get it really to run cheaply. 10x would be pretty prohibitive. Nevertheless, they announced yesterday that GPT is coming to, that large language models are coming to search. And this is just talking about the inference costs, right? On the other side, we have also the training costs. The training costs are only one time. That's a good advantage. And hopefully someone else will actually do the training and give you the model. But GPT cost more than 4 million in estimated cost to have been trained. And for GPT-4, they say it's more than $100 million. So it's very expensive. Here's some new thoughts that come up recently. Sam Altman has been also saying that the age of large language models is already over. That's how fast things move. I don't know exactly why. Maybe they're running out of text to read. So one of the things they say is that reading more text gives diminishing returns, which makes sense. If you're reading like 100 million books, you probably don't have that much new to catch up. But they're not planning to do a GPT-5, is what they say. Sure, and that's great. They need new ideas, and that's great because there's a lot of problems with the current systems, as we're going to talk about. But also one thing is when Meta released LLaMA, their own model, one thing that happened is that we see that the community outside of OpenAI, the community outside of Google is extremely creative and very fast in doing stuff. They managed to run LLaMA on, first on normal consumer hardware, then they made it run on a phone, and then they made it run on a Raspberry Pi. It's very slow. It takes a few seconds to generate a single token, but it works. This doesn't mean it's getting cheaper than knowledge graphs, though. It's still the same problem. You still have to do all these multiplications, whether you're doing it on a Raspberry Pi or you do it on A100. So here's a few challenges that we encounter with LLMs. This one surprised me a lot, actually. So a few weeks ago, I stumbled on these Wikipedia rabbit holes where I got temporarily obsessed with a single fact. And I want to figure out if it's true or not. It was the birthplace of a not particularly well-known Croatian actress, Ana Begovic. I was surprised that Google and Wikipedia Wikidata on the other side would give me different answers. Google was saying Turpin, and still does, and Wikipedia was saying split. And I was trying to hunt for sources, and one of the problems is that a lot of the sources on the web got contaminated by Wikipedia. They have created it after Wikipedia claimed that it's split. And it took me a while to find a source which was actually older and could figure out that she was indeed born in Turpin. It's one of the big problems on the information ecosystem out there, that everyone is just copying from Wikipedia, and we don't know what the truth is after a while of wrong facts there. That's a substantial danger, nothing to do with LLMs, but still might be getting worse with LLMs actually in the future. So when I go to Bing Chat, which is basically GPT running with a web search, and I ask for the place of birth, it gives me Turpin, which is great. It gives me 3 sources for that. Unfortunately, if I look one of the sources in Wikipedia, it doesn't actually say Turpin, it says split. So great, thank you for giving me sources that don't actually support your statement. When I go to ChatGPT instead, it gives me split. Unsurprisingly, because the cutoff for training ChatGPT was in 2021, so it wouldn't have an update from 23 when I fixed it to Turpin. Split is expected, no big surprise. What is interesting though is if I ask the same question in Croatian, does anyone here speak Croatian? Or Serbian or Bosnian? Perfect. Yeah, we have you here. So you can vouch for me. This is the same question. I'm asking for the place of birth. It gives me the answer Zagreb. And there's not a single source on the web that says that Begovic was born in Zagreb. There's nothing that connects the two with each other. So why? And I was thinking about it and I was thinking, well, let's try to say something. Maybe, well, she's a Croatian actress. Zagreb is a pretty big city. Croatia is a pretty small country. It's very likely that anyone from Croatia is born in Zagreb. So I wanted to check Wikidata how many Croatian actors and actresses are actually born in Zagreb. And because I was lazy, I actually just asked ChatGPT to give me the query. And it did, and it was almost right. It was good enough for my purposes. So instead of giving me Croatian actors, it gave me actors who are born in places in Croatia. Close enough for these purposes. But the amazing thing is it knew all the QIDs out of it. It didn't have to look them up or whatever. It just has them memorized. I actually can ask for all the QIDs of European Union countries, and it just gives me a long table. All of this is completely memorized in ChatGPT. This is pretty cool. So I just copy and paste this query over to the Sparkle endpoint, to the Wikidata query set, and I get the answer. You can already see it's all Zagreb in the first page. Indeed, of the 445 actors that it finds, 154 are born in Zagreb. So given the prior of Croatian actors saying Zagreb is not a bad thing. But that's it. In Croatian, it's guessing the place of birth based on this prior. In English, it knows that it's split, which is also wrong, and it gives you this information. So it has different knowledge based on your language, which is really weird. This leads me to something that my manager, Jamie Taylor at Google, used to say. You can machine learn the birthplace of Obama every time you need it. But it costs a lot of money and you're never sure what you get about it. Why not just store it once in a knowledge graph and look it up? So much cheaper. And so much more confidence in the answer. Here's a quick one. So another question, I tried to come up with a question which is probably not already a listicle or somewhere in the Google corpus or in the web corpus. So I was asking for mayors of cities that are born after 1998. And ChatGPT correctly points out that, well, they would be too young to be mayors. There's nothing like that. So I'm going to Bing Chat. Bing can access the web, so maybe they have any information. It's like, no, too young, can't have anything. So I go to Wikidata and ask the same thing. I again used ChatGPT to create a query. This time I didn't get it right. I had to fix a few things, but it actually gives me an answer. The mayor of Lichtenberg in Bavaria was born in April 2000. The youngest mayor in Germany. This was in 2020, well before the cutoff for ChatGPT. ChatGPT didn't tell me anything about it. Bing said it doesn't exist. And they hopefully saw this thing. By the way, I'm not condoning the politics of that mayor. So we can go now to Bing Chat and ask him, who's the mayor of Lichtenberg? What's his age? And it will totally answer me that. It doesn't even notice that it's completely inconsistent what it previously said. There's nothing in it that makes it sure that it's consistent across its knowledge base in any way, or even across languages. They're also not particularly good at math. If you ask questions about math, like what's the prime factorization of this, it gives you the wrong numbers. And that's the thing. Why would you ever use a 96-layer LLM with 175 billion weights to generate a math question, to generate a multiplication, which is a single operation with your CPU? Just because an LLM can do this kind of things doesn't mean you should be doing it. Why should you generate knowledge again and again if you can just look it up in a confident way? LLMs are Turing complete. Autoregressive transformer models are Turing complete. Sure, they can do everything a computer can do. No surprise here. But it doesn't mean you should be using it for everything a computer can do, because it's just not very efficient. The way forward probably is having architectures like so-called augmented language models, where you have specific capabilities that you externalize to the LLM and use the LLM to orchestrate between them, to use them as a UX. A good example of that is Toolformer. So I can basically use the large language models as a wonderful UX that tries to figure out what you are trying to achieve and then orchestrates the different services out of it. Like, for example, looking it up in a knowledge base or doing math or doing any other functions like with Wikifunctions. With a mapping of some strategic nodes in knowledge graphs to embeddings, we can connect the knowledge graph directly to the large language models or use Sparkle query generations ability directly. I mean, it does the Sparkle queries already, and it's not even trained on that. And not only can we connect LLMs to a knowledge graph, but we can also use it as a repository of functions such as Wikifunctions. Knowledge graphs and functions would be tools that LLMs can use. Okay. Hi, Marco. This work is trying to understand how knowledge is stored in the parameters of a large language model in order to understand why are large language models actually large. Because do they really have to be this large? Let's think about Stable Diffusion 1. Stable Diffusion is a text-to-image generator. So it has to understand textual input, and it creates images. Here, for example, I'm asking it for several celebrities to explain the advantages of knowledge graphs using a whiteboard. And we have the Pope, we have Greta Thunberg, we have Idris Elba, Michelle Yeoh, Helen Mirren, and Jan LeCun all saying how great knowledge graphs are. And those people look recognizable like them, right? I mean, so we have a model that can create all those pictures, can understand those inputs and everything. GPT-3 had 175 billion parameters. How many parameters do you think Stable Diffusion has creating all those images? 890 million. I think 890 million is a lot, but compared to GPT-3, it's tiny. It's 200 times smaller. And this is no surprise. Think about it. All the knowledge we're using for answering our questions so far, the embedded QIDs, which countries are members of the European Union, the place of birth of individual peoples in several different languages. There are millions of people it knows the place of birth of in several languages again. So this costs parameters, a lot of parameters. Billions of those parameters are filled for this kind of trivia knowledge that we could easily put into a knowledge graph. So do we really need this for text generation, or do we just need it because, well, end-to-end knowledge stores seem to be better? If you take, for example, Meta's LLaMA, which came out a few weeks ago, it came in different sizes, and the smallest one is about 25 times smaller, 7 billion weights. And it's pretty competitive in terms of language understanding and fluency. Not in a lot in question answer necessarily, but that's okay. But do we really want to internalize 1 billion statements from Wikidata in those knowledge graphs? We could just go the other way around and use those knowledge graphs as the world's best knowledge extraction mechanisms. We can use them on text and get the information out in forms which can be expressed in knowledge graphs, store them in the knowledge graphs, check them there, edit them there, curate them, and have them, oh, I'm running out of time. So in a world where models can generate infinite content, knowledge becomes actually very, very valuable. And this comes back to Jamie's rule. We don't want to learn every fact every time again and again. We want to have it once and store it. I want to have that the knowledge about Obama's birthplace is in Wikidata, and that's it. Everyone can look it up. It becomes a common good. It becomes very valuable. And we can use LLMs for knowledge extraction. We want to extract the knowledge into symbolic form, and we want the system to overfit for truth. We want to have a place where we can say, this is your truth store. This is your ground truth that you can use and you can rely on. And this is what makes so much sense to use it in a symbolic system, one that can be edited, audited, curated, understood, where we can cover the long tail by adding more entities to it. We don't have to train again and again in order to make any knowledge into it. I want to make one suggestion in particular. So free-based, knowledge graph, Wikidata, they all had some special kind of values. You could say, for example, Elizabeth I didn't have a child, so it has a no value node on that one. Or you can say, well, someone has an unknown value. Like, for example, Adam Smith, we know he has a father, we don't know who it is. So he has an unknown father. I want to introduce a third new special value into knowledge graphs, which is it's complicated. Usually I get laughter when I say that, and I made this suggestion like half a year ago at Google. They laughed and they thought it was an April Fool's joke. But I'm actually quite serious about this. If you put this information in knowledge graph, we know that this is curated to be complicated. And we can, for example, tell an LLM to spend a few more parameters, to spend a bit more time on checking this particular effect and learning about it, for example. And we can spread out strategically where certain knowledge in the system is stored. Knowledge graphs are of limited expressivity. And it would be great to understand in which places we need to push out of this expressivity. So in Wikidata, we are working on Abstract Wikipedia Wikifunctions, which is aiming to extend the expressivity of Wikidata considerably. For example, to be able to say a statement like Jupiter is the largest planet in the solar system, which is not something which you normally would have explicated in a knowledge graph. So to have this, it's complicated thing would give you the information to, oh, this is maybe something we have not explicated yet in a knowledge graph where we don't have a ground truth. Use maybe the LLM on that. Summary. Large language models are truly awesome. They are great tools for understanding language, which can really bring a revolution in how people are using computers. As a UX tool, they're just breathtaking. But they hallucinate. They need ground truth to access. Knowledge graphs can provide that. They are expensive to train and run. They are difficult to fix and repair. And try to tell your boss, oh, sorry, I can't fix the fact that it's telling you the wrong data here or the wrong price for something. They're hard to audit and hard to explain, which is something which is probably crucial in finance and medicine and other use cases. They give inconsistent answers. They struggle with low resource languages. They have a coverage gap on long tails, and all these problems here. They have many other problems, but these problems here at least can be solved by connecting them with knowledge graphs. This is why I think that the future of knowledge graphs is brighter than ever, especially thanks to a world that has language models in it. Thank you for attention, and thank you for everyone who helped with me. We have still about 3 minutes for questions. I have no idea how online questions work, but I can take audience questions at least.
Wikifunctions, now the answer.
Wikifunctions, the question was this. Yeah, I think that Wikifunctions together with LLMs can be extremely valuable. To have a big repository of functions that can answer a lot of questions in a confident way and attach it together with LLMs who can understand your query and then use these answers, I think this will be a magical combination. In general, actually, this is already something, for example, that Wolfram Alpha is working on with GPT and others, which is exactly the same architecture.
Now, you know I'm a fan of knowledge bases, but I'm just as a devil's advocate here. Everything said, hey, write it down in the knowledge graph. Write it down in a database instead. Why a knowledge graph and not just some plain old database?
Oh, I wouldn't make that huge a difference between these two, to be honest. As long as it's structured data, this is the one big thing where you have ground truth which you can explain and so on. I think that graph databases, knowledge graphs, have the advantage that they're a bit more flexible than many relational databases. But this is getting to the point where it's like an internal fight between the. It doesn't really matter. So I don't think that's the important part here. The important part is structured, explicit data versus weights in an LLM.
One more question. So just a few days ago, you know, these things happen in days, right? Not in weeks. And there was this publication from Microsoft research guys on causality, right? So which basically they claim that causality works extremely well through LLMs, right? So expanding, right, knowledge base with causal connections, which are at the moment they are weak, right? So here I see one big opportunity as well. So something which we didn't have and may come for small cost at the moment, right?
Yes. Yes, and I wouldn't be surprised if there is even more interesting architectures where some of the causal reasoning can be maybe put to to a logic reasoning system or something like this and combine it all together. But yes, I think there's a lot of opportunity if we are open-minded about using those different systems and then playing all the different strengths together instead of just putting on one, put all bets on one horse. Juan?
So one of the takeaways I'm having is that it's cheaper to go answer some question. So if you look at the input and output, if you given that input and you want that output, you have two options. You can use a large language model, you can use a knowledge graph. And one of the takeaways I'm having is sometimes it's much more cheaper to go to with a knowledge graph. So do you think we'll get to a day that it's after the hype, people are going to start being very cost conscious and like, is it actually worth it? Or do you think it's like, we're just going to eat up the costs and yeah, that this is the new world. I mean, things get more expensive. I mean, basically, is the cost an argument really big here that we're gonna that will slow down the hype?
Well, it's not my only argument, right? There was also expandability, editability, and so on. But I think money runs, and I think it is actually a strong argument. First, if you can only run it, if you can't even buy the hardware right now, which is basically a limitation, right? I think the cost makes it. I'm in America, so yeah, I do think money talks. I think that a 50x difference in costs matters, and sure, it will get cheaper in the future, but so will also knowledge graphs. So. Yeah, I think the money argument. You're dealing with companies much more than I do. I'm working for the Wikimedia Foundation. I have a very different relationship to money. I know.